All right. Colored pens up. We have an assortment of questions from throughout Chapter 7. Let's see how we're doing on all these different ideas, all relating to percents. Number 1. How much money did Stella pay? Start with Steven, and then Fancy, and then Nolly. Okay. Okay, but I volunteered. Oh, I apologize. Nolly? You didn't get an answer for it? Did you get part of an answer?
Yeah, but I didn't write it down. I just put it in the calculator and I messed up.
How do you know you messed up?
Because I didn't mean to. Like my finger did not correspond.
Oh, so you're saying physically something went wrong that you didn't plan on and you didn't get a chance to redo. Got it. Catalina?
Oh, I got. I don't even know. 1,500,500. This one. 15,807. Wait, no.
Okay, so I'm going to stop you there, because if you can't even say your own answer, then not sure what we're going to do with that. So we got Essence, and then Savannah, and then Annie. What'd you get?
15,580.
Okay.
$14,196.
Okay.
56,629.
Okay. Catalina, you want to give it another shot? Go ahead.
15,878.80.
Okay. The correct answer is 20,000.
Wow. I was real close.
Okay. Now, first of all, let me be honest about that question before I go ahead. I've been using this question for, I think, 2 years now, and I don't think I've ever had a student ever get it right, ever. So, if you got it wrong, that's my expectation. What I wanted to see is your process and your effort. I wanted to see what you tried to do, and I walked around and I saw people make effort, working through it somehow. There's going to be questions like this on the FCAT. There's no such thing as skipping questions. So you have to do something. So I wanted you to actually make an effort. We're going to talk about how to do this in a couple of minutes. Number 2, what'd you get? What's the total cost of that? DeAndre and then Cameron.
$319.93.
Okay.
$319.93.
So you agree. It is $319.93. What about the cell phone with a 20% discount? Angela and then Annie.
$63.
Okay.
$94.
Okay, so we have a disagreement. Steven?
$63.20.
Okay.
Wait.
It's $63.20. What about a percent of change? Number 4, what'd you get? Chelsea and then George.
The decrease of 15.68%.
Okay.
A decrease of 15.67%.
Okay, well, about the same answer. I rounded mine off. It is a 16% decrease. 15.68, I believe, is what the actual number is. That's fine. Number 5, what is that percent of change? Start with Kiara, then Amani. Okay? Okay. Comes out to a 22% decrease. I believe you were very accurate with your answers, so that's very good. And going way back to the beginning of the chapter, what did we get for 140% of 60? Start with David and then back to Angela.
84.
Yeah, it comes out to 84. What about number 7, 15% of 290? What's that? Savannah and then Nolly. Okay? Yeah, it comes out to 43.5. And 80% of what number is 94? We got Cameron S. and then Tristan.
117.5.
Okay. 117.5, you got the same exact thing? Okay, the correct answer is 117.5.
Oh.
So being 1,000% honest, I feel strongly that every single one of my students in this class right now should have gotten 2 through 8 correct with, just a moderate amount of effort. These are all low-level questions. There's not really a lot of thought involved. Number 1 was a very high-level question. So I want to take a minute for that. Have your colored pen ready. And I want to show you how what you're studying this year and what you're going to be studying next year is so critical. Percents don't work like other numbers. The issue is that when you find a percent of a number, you're basically finding a part of a number. And so you can't really add percents together if you're going to take a percent and then another percent. Because if you take, let's use a nice friendly number. Nice friendly number and all eyes up here. Let's just start with 100. If I want to take 50% of 100, and then I want to take 20% of the result. No, let me do it differently. If I want to take 50% of 100, and then I want to take 50% of the result. Well, that's 100%. So would that mean that my answer was 100? Can you take the 50 and add it to the 50 and say, now take 100% of 100? Percents don't work like that, because when you're doing one after the other, you have to wait till the first one's done. You have to wait till the first one is done. So if I wanted to take 50% after this, watch what has to happen. You have to take 50% of 100 first. What's 50% of 100? Savannah? 50. So this equals 50. Now if I wanted to take 50% of that result, that's 50% of 50. What's 50% of 50? Cameron?
25.
25. So are you allowed to take these 2% and add them together and then apply it to that first number? Can you do 100% of 100? That's 100. So that doesn't work. And actually, it doesn't work for any percents if you're doing one after another. And that's usually what's happening. And that is what is happening in this case. Not only that, but you're working backwards. And working backwards with percents is horribly, horribly difficult. Incredibly difficult. I feel confident in saying if I gave 100 of the teachers, I don't know if there are 100 teachers, 75 teachers in this building, this question, I'd be willing to bet maybe 5 could get it right at the most. Because working backwards is hard, working with percents is hard, working backwards with percents is incredibly hard. But watch how algebra completely magically transforms everything. Now, I don't expect that you're going to understand everything I do. In fact, you're not. I'm going to explain a couple of the numbers that I'm using, and if you get it, great. If you don't beat yourself up, don't get upset, because eventually you will understand. So, first of all, we don't know the beginning. We do know the end. In algebra, when we don't know something, we use a variable, and that's the whole purpose of algebra. So what I'm going to say is, since I don't know what Stella paid, I'm just going to call that X. That's my starting point. But what I do know is that Stella then sold the clothing for 60% more than she paid it. So 60% more than she paid. Well, guess what? She paid 100% for it. Because whatever she paid doesn't matter. She paid 100%. Now she's going to sell it for 60% more than that 100%. You are allowed to take the 60% and the 100% and combine them together because she's selling it for 60% more than she paid. The way we write that as a number is we do not write 160% X. We don't write that. We have to convert the percent to a decimal. What is 160% as a decimal? David?
0.6.
160%.
Oh, as a decimal?
1.6. So what we're going to do is take her original amount and multiply it by 1.6. That's going to take care of that right there. Second event that happens is she's going to sell the clothing for 12.5% off. Here's something that I had expected some of my students to pick up on, but nobody said anything yet. If it's 12.5% off, what percent is on? If it's 12.5% off, what percent is on? Stephen?
87.5.
Yeah. That's how discounts work. Is if you're taking a part off, then you're actually paying the part that's on. So in this case, it's 12.5% off. That means it's 87.5% on. To make it a little easier to use a friendly number, you walk into Old Navy and there's a big sign that says, jeans, 30% off. What percent do you pay? You pay the 70%. So instead of finding 30% and then subtracting it, if you can find 70%, you've already figured out the price. So in this case, we have to take 87.5% of this. So we need to take this number, and I'm going to move it over a little bit so you can see what I'm doing. And I'm going to multiply it by 87.5%, but you write that as a decimal. 0.875. That takes care of that. The last event that happens is 6% sales tax gets added on. So we got to take care of that. Tax is extra money that's paid, right? It's extra added on to the 100% of the money that's been spent so far. So if we take 100% and add 6% to it, what percent is that? 106%. So we now need to multiply this whole thing times 106% written as a decimal form, like that. This thing that looks pretty messy, but you're going to see in a moment it's not, must be equal to 29,680. Now, believe it or not, you already know how to solve this, you just don't realize it. If you have a number times a number times a number, you can just multiply them together. In fact, they're all being multiplied by this variable. It doesn't really matter. It's just four things being multiplied. The variable we can't do anything with, but we can multiply the numbers times the number. So pick up your calculator and watch this. Do 1.06 times 0.875, hit the equal sign, times 1.6, hit the equal sign, and you get 1.484. 1.484x equals 29,680. How many steps will it take to solve that equation? Angela? 1. Divide both sides by 1.484. Go ahead, pick up your calculator and do 29,680 divided by 1.484. George, what'd you get? You get 20,000. So there's no way I expect you to know how to do this. And my point here is not for you to leave here knowing how to do this exact question. But I wanted to open your eyes to the fact that algebra makes this actually moderate level. Without the algebra, this is nearly impossible. So think about that. Without this concept, this overall concept that you're learning, you wouldn't even be able to be successful at all. Interesting. Okay? Comments, questions, concerns? Okay. Today we're going to complete our study of applying percents with the idea of simple interest. First, give me a thumbs up if you have a bank account in your own name. Good, quite a few of you. Put your thumbs down. My students who did not put your thumbs up. Students who did not put your thumbs up, listen carefully because you have an additional homework assignment tonight. We're going to go home. You're going to ask your parent or guardian if sometime soon you can go to the bank together and open up a bank account in your name. Children's bank accounts can be opened with just a tiny bit of money, $1 probably or something like that. Not a big deal, but it's an experience you need to have. It's something you need to experience and learn about. You need to go to the bank. You need to understand what that feels like. You need to ask questions. Okay? Today you're going to be exploring an idea that's kind of the simpler version of the way banks work today. It's called simple interest. Before we get into the idea, we have to get some vocabulary down. First, interest. Well, basketball is one of my interests, so is reading. But that's not what we're talking about. We're not talking about interests. We're talking about a banking term. Interest. Interest, in terms of banking, is money that you are paid for letting someone use your money. Or it's money that you have to pay somebody else because they loaned you money. That's interest. Principal. Principal is the person in charge of this school. But that's not what we're talking about. We're not talking about the person in charge of this school. We're talking about a banking term. The amount of money that you put into the bank or the amount of money that you borrow from someone is called the principal. You can think of it kind of like the starting amount. Kind of like the starting amount. The annual interest rate. And from now on, I will refer to it as the rate. This is the percent by which the bank determines the amount of interest you're going to earn, or the bank or credit card or person determines the amount of interest you owe. And lastly, balance. To surf here in Florida, you need very good balance. But that's not what we're talking about. We are talking about a banking term. The balance means your principal plus your interest. In other words, the original amount of money you put in plus the money that the bank gave you. That's your balance. Today's concept is a good news, bad news concept. The good news is it's all based on one formula. Very good news. The bad news is that there are a couple of details that you have to pay very close attention to. In fact, if you think about it, all year I've been talking to you about details. I always make this same joke over and over again about someone being fired, right? That, oh, you missed a negative sign, you just got fired from your job. I say that jokingly, but it's very serious because everything is about the details. The details are everything. So, the formula. The formula is I equals PRT. It's super easy to remember because it's the I am pretty formula. I am pretty. So it is super easy to remember. I stands for interest. P stands for principal. R stands for rate. Those are all terms that we just learned a little bit about. The T, I don't see any word other than the that begins with the letter T, or that. Does anyone know what the T stands for? Catalina? T stands for time. However, there's a couple of details with the formula, as I said. First of all, the rate. The rate must be in decimal form. Must be in decimal form. It would help if I spelled decimal correctly. Decimal form. That's actually easy. You guys know how to convert from percents to decimals, and I'm going to review it in a minute. The other detail is a little bit more challenging, but not really too much so. Time must be expressed in years. It cannot be expressed in months. It cannot be expressed in decades. It cannot be expressed in days. It has to be written in years. And so whatever measurement of time is introduced has to be converted. So let's talk about the years first. And we've done conversions like this before. We never did it with years. We did it with time on a clock. And we've done it with a couple of other ideas. Now, the formula uses only years. So if you wanted to put in 9 months, you can't put a 9 because then the formula thinks you're saying 9 years. So what happens if you want to put 9 months? You have to convert it to a decimal form of a year. So here are a few examples. 4 months. It's easy to convert. Because there are 12 months in a year, you just take the number of months that you have and divide by 12, and that will give you the months as a decimal. And this decimal is basically telling you what portion of a year that number represents. A 4-month period is really 1/3 of a year. What about a 10-month period? 10 divided by 12 comes out to approximately 0.833, and that's actually a repeating number, but it's not practical to use all the digits, so we round it. "18 months. That's more than a year, but it's expressed in months. So you take 18, divide by 12, and you get 1.5 years. No matter what, the formula must be in years. Any comments or questions about that? Yes, and then yes.
So what she's saying is that if we have less than 12 months, we can use decimals to express it for years.
That's right. But you see, it also worked for more than 12 months. It was 18 months. But that also, the only time you don't have to worry about it is whether it says years or if the number of months is a multiple of 12. So if it says 24 months, no big deal. 36 months, no big deal. 48 months, no big deal. But what about 50 months? What about 27 months? So these are numbers that are a little more difficult to work with. The other part is writing your percent in decimal form. For you guys, this is something you became an expert at last year. Converting percent to decimal. If you were lucky enough to have Miss Cooper, you learned her little memory device called Dr. Pepper. And this will help you tremendously to remember which direction to move the decimal. When you're going from percent to decimal, you start at the P and move to the left. The reason Dr. Pepper is so important is because it reminds you that you have to move 2 decimal places, not just move the decimal in front of the number. Yes, this decimal does go here. Yes, this decimal does go here. But no, the decimal does not go there. Because it just so happened that these 2 numbers were 2-digit numbers. This one was not. You have to go 1, 2, and fill in a 0, and that's why you get 0.05. Must pay close attention to that conversion. Any questions or comments? Good. Let's get into it and start using the formula. Example 1. We have a fantastic character named Samantha. She's got some money. She's going to give it to the bank to hold for her. So, to figure out how much simple interest she will earn, we need the I am pretty formula. I am pretty. Fill in the pieces of information and make sure any numbers that go into the formula are in the correct form. We are looking for interest. The question says how much interest. So we are looking for the letter I. So that's going to stay a letter I. Principal, $12.50. That's the starting amount. Times the rate. It's 4%, but you can't put a 4. You have to write it as a decimal, and what's 4% as a decimal? Adriana?
0.04.
Very good. 0.04 times a number of years. Luckily, in this question, it just says 3 years, so we just put 3 because we don't have to convert it. It's already in years. Now it becomes a calculator problem. Pick up your calculator. 1250 times 0.04. Push the equal button. You don't even need to use the calculator for the last part. Times 3. How much interest will Samantha earn on her money in the bank? Cameron?
$150.
$150. Very good. $150. Yes.
Will she have to pay extra for that? Or
No, this is how it works. A bank account is you giving the bank your money, and they hold it and keep it safe, but they also use your money. They actually use your money to make investments so that they make money. And so what happens is then they give you a little bit of extra money back. So here's the cool part about bank accounts. Samantha put in $1,250. Does she only get $150 back?
no, she gets
What does she get back? George?
$1,400.
How'd you get that?
Because you add
comfortable with 50
Yeah, the balance is the original amount, her principal, plus the 150. This is the money that the bank pays her so they can borrow her money. So you are getting money for doing nothing. Now, unfortunately, at this point in our world, banks do not pay this high percent interest. In fact, the percent that they give you is extremely low. But it's still money for doing nothing. So if you can open a bank account with $10, you will get a few cents extra every month. And the cool thing is that the money goes right into your account and it keeps accumulating more and more and more and more. So banking, incredibly important for you to experience. Yes, Savannah.
Oh, does it go up each month or does it stay the same?
The rate, the 4%.
No, the interest.
Well, it just keeps on going. So think of it this way. This 150 goes back in with this and now becomes $1,400. Now the $1,400 gets 4% interest. Then she gets interest on that and that gets added in. Now it's even more money. And then that gets 4% interest. And then it keeps getting added on and added on and added on. And so your money starts growing faster and faster and more. So again, unfortunately, banks at this point are less than 1%. They are now offering 0.5%, stuff like that. But it's still money for doing nothing. So it's something that you should be doing. Okay? Comments, questions, concerns? All right, so let's change the scenario. We're going to stick with the same character. But we're going to change the story a little bit. How much interest will she earn if we bump up the interest rate, because she's a great customer, to 4.75%, but then something happens in her life and she needs her money, so she takes her money out after 9 months. What happens then? Well, no matter what, it's still the same formula. It's the I am pretty formula. We're going to start at the beginning of the scenario. She still has $1,250. But this time, the rate is 4.75%. Now we need that in decimal form. What is that as a decimal? Essence? Now that's very good, because most students go, oh, well, it's just 4.75. There's a decimal right there. There's a difference between there being a decimal and something being in decimal form. This symbol right here means it's in percent form. Decimal form means we actually have to convert it using Dr. Pepper, and Essence was right. It's 0.0475. Now, she's only going to leave her money in for 9 months. Now, we cannot put a 9 here, because if I put a 9 right here, that means 9 years. So I have to convert 9 months to something. What will 9 months be so that I can put it in there? Cameron?
0.75.
David, do you agree with that?
Yes.
Yeah, because 9 months is actually 3/4 of a year, and so it's 0.75. Once we have it set up, it becomes a calculator issue. 1250 times 0.0475 equals times 0.75. How much money does she earn over the 9 months? 2 people are able to do it? 3 people? 5 people. Tristan? $44.53. You can't just disregard this, but you have to round it. That's a 1, so that's going to stay 53. So it's $44.53. Very good. $44.53.
For the first one, if you have a you said that you get a 0.05% of interest right now, you would only be earning you would only have 18.75 of interest.
Dollars? $18.75? Yeah, you make a lot less money, but the idea with putting your money in a savings account is you put it in there and you leave it there. You leave it there for a long time, and as I was trying to explain, this is the part where I'm simplifying things a little bit. Your money that you make goes right back into the account. Then the percent gets taken on your new amount. Then they add on more money, and then it gets taken on the new amount. It's called compounding interest. It means your money grows, and then your money grows on top of the growing part. And then your money grows on top of the part that grew already. And it keeps growing and growing and growing. And so at first it seems very small. And it seems small, and then it seems small, and then all of a sudden it gets a little bit bigger, and then all of a sudden it starts growing faster and faster. It requires it leaving it for a period of time. I mean, look at what happened in our scenario. The first one, her interest rate was 4%. The second time was 4.75. She should have earned more money here, but she didn't. Because in this scenario, she left it in for 3 years. In this scenario, she left it in for less than a year. So here she earned $150. Here she only earned $44.53. So the time was very important. The amount of time that was left was very important. Okay? Good. Any comments, questions? Good. To the boards. Checkpoint number 1. Well, I'll only this last time, but I believe I've asked you to get dry erase markers, but you didn't go home and ask. So I keep letting you off the hook. If I give you a dry erase marker every time, then you'll never go home and ask. I don't know. Does it say dry erase on it? It has to say dry erase. Did you hear what I said to him? Okay. So you got 2 parts. So you're going to have to divide your board straight down the middle, going the landscape way. Here you go. You got 2 questions. You got 3 minutes. Remember to use the space on your board so that things are nice and big and easy for anyone to see. Again. wrote is perfect. I said what you wrote was perfect. What you wrote is perfect. Something does not look All right, let's see it. Okay. Can't see that at all. Gotta make it much bigger. Even essence, gotta pick it up no matter what. Sorry. Okay, put your boards down in front of you. There's good news. Almost everybody got it correct, both of them. And in fact, there's more than one possible answer. There's a best answer, and then there's other answers that I will accept. So here is the best answer. Do not erase yours or react to yours, because that's the answer if you convert 8 months and round it to 0.67. That's rounding it. Now, some people did 0.66, and in that case, I believe your answer comes out to $59.98. Then there's some people who who did 8 divided by 12 and left it in the calculator. So it came out to 0.6666666666, and then you multiplied it out, and in that case, I believe it comes out to $60.59. So I will accept those three answers: $60.89, $59.98, or $60.59. Now your balance will depend on what number you had over here. But your answer should be close to $628.89. If your answer was the $59.98, then you're going to be 91 cents less. So I think you would be $627 and...
I wrote this wrong. Sorry.
98 cents, yeah. Okay? Comments, questions, concerns before we erase our boards? Okay, go ahead and erase your board. Either slide it underneath your binder or put it along the leg of your chair. And let's look at the other perspective. So far we've explored the perspective of us giving our money to the bank and letting them hold it and giving us interest. The opposite perspective is when we need extra money to make a large purchase of some kind. There are some very common ones, such as buying a house, buying a car, doing upgrades to your house, paying for college. So these items are too large for the average person to pay for just by paying for it. So we take out loans, and it's very, very common. But you get the money with the understanding that you're going to pay all the money back plus interest. So the banks and the companies that loan money make lots of money off of you. They loan you the money, and then you have to pay it back with some extra money. So let's look at a fictional scenario, but it's very realistic. We have this awesome young man named Randy. He wants to buy his first car, so he doesn't have enough money to buy a car. Most people don't. So he goes to the bank and says, "Excuse me, Gallup Bank and Trust. I am a nice young man. I have a clean credit history. I've never done anything wrong with money. I'd like to borrow money to go buy a car." And the bank says, "Sure. You can have $15,000 to go buy a car, but we're going to charge you 7.5% interest." So let's see what happens. So, no matter what, it's still the same formula. We're just looking at it from the opposite perspective. So, it's the I am pretty formula. And the principal, again, is the starting amount. In this case, it's the amount of money that's being borrowed. It's the $15,000. The rate is 7.5% per year. Now, we cannot put that into the formula until it's in decimal form. What is 7.5% as a decimal? 3 people are able to do that? Don't have confidence yet in this? Amani? Very good. Dr. Pepper. 1, 2. Fill in a 0. It's 0.075. Let's see what happens if it takes Randy 3 years to repay the bank. So let's see what happens for 3 years. Now it becomes a calculator issue. 15,000 times 0.075 equals times 3. How much interest will Randy pay on his car loan? Kiara? $3,375 is the interest he will pay. How much total does Randy have to pay the bank? Tristan? $18,375 total is what he has to pay to the bank. So his $15,000 car cost him $18,375. It's a lot of money. It's a lot of extra money. But here's the thing. Would Randy have been able to buy the car if he didn't take the loan? No. So Randy gets what he wants. He gets the car. The bank makes money off of him, so the bank gets what they want. The car dealership gets what they want. They wanted $15,000 for the car. So everyone pretty much gets what they want. But you just have to keep in mind that when you buy something of this size, of this amount of money, you pay extra. You pay more than what it actually costs. Okay? Any comments, questions, concerns? Yeah? Well, it kind of depends, but yeah, pretty much you pay monthly. So So I'm simplifying the situation a lot. He wouldn't, after 3 years, pay one lump sum of $18,375. He would be paying as he went along. However, for the purposes of this class, we're doing it this way. Okay? It's a very good question. But let's take a look at a situation kind of like what Kiara was just suggesting. We have another awesome character named Deshaun. Deshaun is going to do something that people all over America are doing every single day. It's happening right now as we speak, probably just down the road, where people are using their credit card to pay for not the hugest purchase, but a purchase too big to pay in cash. So they use a credit card, such as buying a new refrigerator. He's going to pay for a $900 refrigerator, but his credit card charges 19% interest. How much will he owe after 1 month? So let's see what happens to Deshaun. It's still the I am pretty formula. And this time, the principal is the $900 item. The rate is 19%. What will that be in decimal form? Essence? 0.19. Very good. But what about the 1 month? We can't put a 1 because 1 would mean 1 year. So we need to express 1 month somehow. What will 1 month be? Catalina?
Wait, 0.33.
Can't be 0.33 because that's 1/3 of a year, and that would be 4 months. So-
I got that wrong. It's 0.083.
That's right. So it comes out to 0.83333, but we don't keep on doing it. We round it off. 1/3 will be good enough, and I forgot a 0, sorry. 0.083. So now, once again, it's a calculator issue. So let's see what happens to Deshaun. His $900 refrigerator at 19% interest for 1 month. How much interest will he pay? Cameron?
$14,193.
What?
Wait.
Whoa.
$14.19.
Well, why don't you think about it before I fire you from your job?
Wow.
Which one would make more sense?
$14.19.
Okay. So $14.19 certainly makes much more sense. So, hold on. $14.19. Very good. $14.19 is the interest. But so how much does he owe after 1 month? How much does he owe, David?
$914.19.
He owes $914.19. So that's not so bad, right? You know, if you don't have $900 but you want the new refrigerator, well, that's not a bad deal. But that means that all of a sudden now next month you have $914.19. What if Deshaun says, I'm not going to pay it for a year? Let's see what happens if Deshaun waits a year to pay. $900 times the 19% interest times 1 year. How much does his refrigerator cost him now? Chelsea?
I think $1,000. Yeah, $1,071.
Yeah, now it's going to cost him $1,071. That's for waiting for 1 year. Guess what? Most Americans, unfortunately, wait a very long time to pay off things like this. And they don't realize that their money is just flying out the window. Think about that. A $900 item, you wait 1 year, it costs $1,071. What do you think is going to happen after 2 years and 3 years? It just keeps exploding more and more. Okay? So credit cards are very powerful and very important in the way our economy works, but you have to be extremely careful. You have to know that the money is coming to pay for it. If you don't know where the money is going to come from to pay for something, then you shouldn't be paying for it no matter what. Okay? Good. So now we've seen loaning money. Now we're borrowing money. Let's see how you do with Mac. Pick up your board. One question. You got 2 minutes. All right, let's see. Put your boards down. Do not erase. The correct answer is $2,135. So, there were a couple people who did get the question wrong, not because you didn't know what you're doing, but because of reading. The reading issue is that it says, how much will he pay altogether? So you had to take the interest and add it on. Most of you caught it. Most of you got it right. Are there any comments, questions? Good. We are doing extremely well. Erase your board and please lean it against the leg of your chair so it can be picked up and put away. We have one last scenario to explore. And the last scenario is where algebra comes into play. What if you were trying to figure out what interest rate you would need to have to earn a certain amount of money or to reach a goal, but you knew all the other pieces of information? So here's an example. if you deposit $900 into an account, and it's going to earn simple interest, but you don't know the rate. After 8 months, the balance is $913.20. What was the rate that made that happen? So it's still the same situation. We're just looking at it from another perspective, which is that something else is missing instead of the I. It's still the I am pretty formula, but we've been looking for the I every time, and now this time we're looking for the R. And this is where algebra and your skills from the beginning of the school year come into play. Your solving equation skills. So let's fill in the pieces of information we know, and let's see if we can work this out. We're working together as a whole group. What's the principal in this case? Kiara? Yeah, it's still the beginning amount, the $900. The R, we don't know. So that's going to stay in R. The time we know, 8 months. We've already done this conversion. What should it be? Essence? Very good. 0.67 is the best estimate of that. So we know this and we know this. We don't know the R. We actually know the interest. What is the interest? Adriana? Well, you're in the ballpark, but that doesn't say the interest. That's the balance. The balance is $913.20. That's not the interest earned. So what's the interest earned? Cameron? How'd you get that? That's right. So you subtract this from this, and you get $13.20. So don't sweat it, Adriana. That's what I was expecting the first person to say. I was expecting anyone I called on to say the same exact thing, and it's happened in every single class. But now we know that you can't just look for the other number. You actually have to think about it. So now we have a formula with only one variable missing. Now we can solve. You learned a long time ago that when you have multiplication, the order of your multiplication that you do doesn't matter. 2 times 3 times 5, 3 times 2 times 5, 5 times 2 times 3, 3 times 5 times 2. They all come out the same. The order doesn't matter, which means that you can take this number and move it over here and multiply it. Or you can take the middle number and move it over here and multiply it. It doesn't make a difference as long as everything is multiplication. So the same thing is going on over here, just with less friendly numbers. So we can take this 0.67 and multiply it times the 900 because we're allowed to do that. So pick up your calculator. We got 900 times 0.67. What do we get in the calculator? DeAndre?
603.
Yeah, we get 603. So look at what we're left with. We are left with this. 1320 equals 603 R. How many steps does it take to solve that? George? It's a one-step equation. How do we solve it? What is the one step? Oh, come on. 6 of my students know how to do that? Angela? Not only does she know how to do it, but she knows how to explain it perfectly. Divide both sides by 603. This disappears. What do we get for the value of R? What do we get for the value of r? Kiara?
2 cents.
Okay, so 0.02. But I'm glad you said 2 cents. Is it 2 cents?
No.
It's what?
It's 0.02189.
Okay, so you rounded it, and I like how you rounded it. So that, I think, was done perfectly. But my question is still, is that 2 cents? So my question is, what did we just find? What did we find, Nolly?
Wait, are you asking me? Like, we're trying to find the interest rate, and so that means that it can't be cents. It has to be not a time, like a rate.
Okay, and the rate in every question we've done so far has been in what form? Amani?
It's been in percent.
Good, so what is this number?
That is 2%.
She said that perfectly. That's 2%. Because remember, when we put the number in the formula, we put it in as a decimal, which means if we find it, that means it comes to us in a decimal form. Now to turn it to a percent, you Dr. Pepper it. And so this is 2%. And so the interest rate is 2%. Okay? All right, we've done a lot today. You guys have done a very good job. We have to modify the lesson. We're going to skip over classwork. That's fine. I'm happy with what you guys have done. Your homework is page 381. Make sure you copy this correctly. It's 8 through 16 even, and number 22, and number 30 to 36 even. That's only 10 questions. Make sure you copy it correctly. And you're going to have a test on chapter 7 on Thursday.